cubic numbers. Okay. They are very much similar to the squares or the square roots. It is just that now they have been raised by a power of 3 rather than a power of 2. So we were talking about 2 to the power 2 or 5 to the power 2. Basically, the base is getting multiplied by itself 2 times. Now in cube numbers, the base will get multiplied by itself 3 times. So if I talk about, let's say, 1 cube, it means 1 cross 1 cross 1, which is 1. If I, let's say, 4 cube, 4 cross 4 cross 4, which is 64, and so on. So now the power is being raised by 3, which means that the base needs to be multiplied by itself 3 times. These are the cubes of the first 10 numbers, 10, 0 to 1 to 10, which you should remember. It is going to come handy in your calculation. Okay. Unlike squares, please remember that unlike squares, your cube numbers can end with any digit. This will also be dependent on the unit digit of the original number. So we will remember that. Odd ka cube is an odd number, even ka cube is an even number. Now, test a perfect square with prime factors. Again, we are going to do the prime factorization like we did for the squares. So 3, 3, 7, 5. First of all, let's divide it by 5. 5, 6, 30, 7, 35, 5, 25. Again, it is a multiple of 5. 5, 1, 5, 3, 15, 5, 25. Again, a multiple of 5. 5, 2, 10, 7, 35. Now it is a multiple of 3. 3, 9, 27. 3, 3, 9. 3, 1, 3. So 3375 is equal to 5 into 5 into 5 can be written as 5 cube, and 3 into 3 into 3 can be written as 3 cube. Now, if I have to take a cube root, which looks like this. So in a square root, you divided the power by 2. In a cube root, you divide the power by 3. So 3 divided by 3, power becomes 1. 3 divided by 3, power becomes 1. So the cube root is 15. On the other hand, if I talk about another number, let's say 500. So 500, 520, 5, 4, 2, 2 and 2. So 500 is equal to 2 to the power 2 into 5 to the power 3. To find out the cube root, this needs to be divided by 3 and this needs to be divided by 3. This is possible, but are you able to divide 2 by 3 entirely? It is not possible. It means it is not a perfect cube. Okay, it is not a perfect cube. Now, cube roots. Try to understand the last digit shortcut. Again, the same thing. So if I talk about the last digit, if the last digit of the original number is 0, so 0 into 0 into 0, the final answer will always be ending with 0. If the last digit is 1, the cube is going to end with a 1. If the last digit is 2, the cube will end with a 2 cross 2 cross 2, which is 8. Last digit is 3, it will end with a 3 into 3 into 3 is 27, to 7 se end karega. Last digit is 4, then the number will end with 4 into 4 into 4, that is 64, 4 se end karega. 5 ka cube is 125, ending with a 5. 6 cube is 216, so basically the number will end with a 6. 7 cube is 343, so the number will end with a 3 if you are doing a cube. 8 into 8 into 8 is 512. It means that the number will end with a 2. And 9 into 9 into 9 is 729. The number will end with a 9. This will also help you in the guesstimate. Okay. Now, there is another pattern like we did saw a good pattern back in squares. There is another pattern for consecutive odd numbers in cubes. So 1, 3, 5, 7, 9, 11, 13, 17, 13, 15, 17, 19, and so on. 1 cube, 3 and 5, that is 2 cube, 3 plus 5 is 8, 7 plus 9 plus 11, that is 27. This is 3 cube. This is basically equal to 64, which is 4 cube, and so on. Okay, we saw a pattern in squares, there's a pattern in the cubes also. Okay, and lastly, there is one thing that this is called a Hardy-Ramanujan number. So G.H. Hardy, this was a story. So G.H. Hardy once told Ramanujan that his taxi cab number was 1729, and Ramanujan had a idea, or basically had a thought that it is a great number because this is the smallest number expressible in sum of two cubes. So basically your 1729 is 1 cube plus 12 cube, and also 9 cube plus 10 cube. So 1 cube is 1, 12 cube is 1728. Similarly, 9 cube, 729, and 10 cube is 1000. So when G.H. Hardy told Ramanujan that this was the taxi cab number, and basically it clicked to Ramanujan that this was something which was astonishing. So that's why this is called the Hardy Ramanujan number 1729. Please remember, it can come handy. And I think that's all for this particular video. These are the things that we discussed in this video. We were able to spot the fake squares. There was a zero rule. Odd number sum was the perfect square, basically starting with 1, then 3, then 5, and so on. How to calculate the fast next square, n plus 1 whole square is equal to n square plus 2n plus 1. Then we did the prime factorization to test whether a number is a perfect square, whether the number is a perfect cube or not. We were able to estimate the cube root and the square root. Then cube, we mapped the last digits of a cube with the original number. And finally, odd factor count. This was something that we were able, these were the things that we were able to discuss, and I think we discussed almost everything which is there in this particular chapter. Please make sure that you watch the next video. We are going to put out every single question into using these tricks, NCRT style questions on squares, cubes, and cube roots. So that's all for the video, and see you guys there.